this kind of system. Problem number 1. You have a convex lens and its focal length is 20 centimeter. Then you have a concave lens, a concave mirror. Okay. The focal length of this concave mirror is given minus 10 centimeter. Okay. And separation between optical center of this lens to that pole of this mirror, this distance is given. This distance is basically 50 centimeter. Okay. Now suppose a plane rays are coming. Plane rays are coming and striking this lens. Okay, so you have to calculate the position of image. You have to calculate the position of image. Okay, so let us solve this question. So you know, when that parallel ray is striking that lens, this ray will be converged. This ray will be converged at a point known as focal. Okay, and if the focal length is 10 centimeter, the distance between optical center and this image point, that will be how much? I can calculate by using this formula. So 1 by v minus 1 by u equals to 1 by f. For lens, I can use this formula to locate or to calculate the position of image. So since rays are coming, these rays are parallel, so basically that u will be infinity. So basically source is kept at a distance of infinite. Now if I substitute that infinity here, this term will be gone and I'll get 1 by v, that should be equals to 1 by m, which means that v equals to f. So you have to keep in mind, whenever you have a parallel beam of ray striking that lens, that position of image will be same as focal length. So I can get that position of image, that will be how much? That will be 20 centimeter away from optical center. Let us give that location of image or notation for this image, that is I1. Okay. Now this image will act as a virtual object for mirror. This image will act as a virtual object for this concave mirror. Okay. So the position of this object, virtual object, will be how much? Distance from pole to this virtual object will be how much? So since this distance is 50 centimeter, this distance is how much? 20 centimeter. Obviously, this distance will be how much? 50 centimeter minus 20 centimeter, right? So basically, this distance you will have, that will be your 30 centimeter. Okay. Now second times, this is like your position of object. So I can write that u will be how much? That will be minus 30 centimeter. Okay. And now I'll use mirror formula. Okay, that is nothing but 1 by v plus 1 by u, that will be nothing but 1 by f. Okay, so this means 1 by v, that should be equals to 1 by f minus 1 by u. And since this mirror is concave, so obviously that focal length will be negative. Okay, and you have this is u this value, u is this value, right? So if I substitute this, basically I'll get 1 by plus 1 by 30. Okay, it means 1 by v, that should be equals to how much? Minus 3 plus 1 by 30. So basically minus 2 by 30. So basically 1 by 15, right? So it means v will be how much? Minus 15 centimeter. V will be how much? That will be minus 15 centimeter. Okay, is this clear? क्या इतना clear है आप लोगों को? So that location of image will be 15 centimeter away from pole. So suppose this is the pole, it will be 15 centimeter away from pole, and obviously this will be in this direction, because this is your now virtual object, so ray direction will be this. So this is actually positive direction, right? So obviously, since you got this v is negative, so that distance or direction will be anti-parallel to positive direction. So this is your pole, so image will be I to somewhere here. This distance is how much? 15 centimeter. Is this
So
clear?
u infinity to u is equal to infinity or given a question.
Not given. You see, whenever you have a parallel ray, for parallel ray u is always infinity, है ना? कभी भी आपका रे पैरेलल करने के लिए आपको सोर्स को कहाँ रखना पड़ेगा? दैट शुड बी एट ए डिस्टेंस ऑफ इंफिनिटी. ठीक है?
Okay, sir.
Okay, shall I erase?
Yes, sir.
Okay. Now you have a another property of lens, that is power, noted by P. The significance of this power of a lens, that it can tells you the ability of converging or diverging ability of your lens. The power basically defines the converging or diverging ability of a lens. Okay, you can mention that can tell you converging or diverging ability of a lens. Okay, so suppose you have a power, if you are getting power that is positive, पॉजिटिव पावर किसी लेंस का मतलब क्या है? दैट लेंस when you are getting power positive of a lens, it means it will converge that beam. It will basically converge the beam or light. For example, power positive किसका होता है? Suppose you have a convex lens, है ना? Convex lens. So convex lens में क्या? Suppose you have this kind of situation. You have a convex lens, and if ray is striking in this lens, what will happen? This ray will basically converge. It will be converged at a point that is known as focus. So for convex, when you have a convex lens at air, this lens will have positive power. Okay, it means it will basically converge. And on the other hand, if you have power that is negative, okay, then it means it represents that lens will diverge. This lens will diverge the light. Okay, the lens will diverge the light. For example, suppose you have a concave lens. You have a concave lens. Now, if suppose the parallel beam is striking here, then what will happen? This beam will basically, that refracted beam will be basically diverge. It will not converge. It will not converge. Okay. So for concave lens, when it is kept at air, this lens will have negative power. Okay. अगर पावर ज्यादा है, सपोज मान लो सपोज यू हैव टू लेंस बोथ हैविंग सेम पॉजिटिव पावर, बट एक का जो लेंस का पावर है वो ज्यादा है दूसरे के कंपैरिजन में, तो हम क्या बोल सकते हैं? सपोज मान लो एक का आपका पावर जो है +2 डायोप्टर है, +2 डायोप्टर है, एक का +1 डायोप्टर है ना? किसका कन्वर्जिंग एबिलिटी ज्यादा है? ऑब्वियसली इसका। ठीक है, अब व्हाट इज द मीनिंग ऑफ कन्वर्जिंग एबिलिटी? है ना? अब इसमें एक बड़ा इंपॉर्टेंट चीज है, सपोज मान लो आपका लेंस, जिस लेंस का फोकल लेंथ ज्यादा है उसका पावर कम होता है, जिस लेंस का फोकल लेंथ ज्यादा है उसका जो पावर है वो कम होता है, और जिसका फोकल लेंथ कम होता है उसका आपका पावर ज्यादा होता है। कैसे उसको समझोगे? सपोज यू हैव टू कॉन्वेक्स लेंस, दिस वन is having a higher focal length, okay, and you have another convex lens, but this lens is having low focal length. So from optical center to this point is basically focus, so this is basically a higher focal length, but this time for this lens you have small focal length. Now suppose a parallel beam is striking here. Again, the property of this convex lens that this ray will be basically converged, but where it will be at focus, right? Focus shape. Same is true for here. Suppose you have a parallel beam is striking. Okay, then what will happen? It will again converge at a point known as focus. But you see, this both lenses are actually converging that ray, right? But here converging rate is small because इतना distance travel कर रहा है पूरा converge करने के लिए। यहाँ जितना सारे आपका ray आया था, suddenly within a very small distance, all rays are basically converged, है ना? Both are converging, but you see here converging rate is small, or here whatever rays are coming, suddenly within a very small distance, all rays are converged. So I can say the converging ability of this lens is higher as compared to this. Okay, so in mathematical form, what I can say that power is basically inversely proportional to focal length. Power is basically inversely proportional to focal length of lens. And obviously for convex lens, when it is kept at air, focal length will be positive, so power will be positive. On the other hand, if you have a concave lens, suppose you have a concave lens, for that concave lens in air, the focal length is basically negative, so for concave lens, power will be negative. Okay, the very simple things. Okay, is this clear? Anju, Rama, Viraj?
Yes, sir.
Okay, so next, another thing that is important for your exam as well, that is refraction. From spherical surface. Spherical surface. Okay. So suppose you have a two medium. You have a two medium. This is medium 1 having refractive index n1, and this is medium 2 refractive index n2. And these two mediums are basically separated by a spherical surface, not by plane surface. Okay. So obviously this spherical surface will have some center of curvature, right? If you complete this surface, or if you complete this sphere, then definitely this surface will have some center of curvature, and it will have some principal axis as well, right? And from distance from principal axis to that center of curvature, that is, there is nothing but radius of curvature, right? So these two mediums are separated by spherical surface, and they have different refractive index. Now suppose this is let us define a principal axis. So principal axis, how will define? So I have to join the center of curvature and pole, and I can extend this line. It should be a straight line. Okay, my drawn is not good, so it should be straight line. Now suppose a point object is kept here. Point object O at a distance of u from pole. At a distance of u from pole. Then this from point object, ray will strike this surface, right? And it will create image somewhere. Let us define that image is creating here. मैंने assume किया कि suppose मान लो यहाँ पे आपका image create हुआ है at a distance of how much v from pole. ठीक है? So there is a nice formula, ठीक है, for that refraction from spherical surface. I'm not deriving anything because these are wasting of time. So this I'll tell you every term. So that is n2 by v minus n1 by u. That should be equals to n2 minus n1 by r. Okay. So again, I'm repeating. You have a two mediums separated by spherical surface. Radius of curvature of spherical surface is r. Okay. Refractive index of two mediums n1 and n2. Okay. And u is basically distance of object from pole. So you have an object here, distance of object from pole to object, that is u, and v is distance of image from pole. So here to here. And n2, n1 you know. But what is n2? How will define n2? क्या है n2 basically? n2 रिफ्रैक्टिव इंडेक्स उस मीडियम का है जिस मीडियम में आपका रे जा रहा है. देखो ये आपका पॉइंट ऑब्जेक्ट है, सो रे विल गो लाइक दिस. सो जिस मीडियम में आपका रे जा रहा है उस मीडियम का है रिफ्रैक्टिव इंडेक्स, दैट इज n2. ये नेसेसरी नहीं है कि इस मीडियम में आपका इमेज बनेगा, दैट विल बी गड़बड़ हो जाएगा आपका. ठीक है, आपको n2 कैसे डिफाइन करनी है? n2 n2 उस मीडियम का रिफ्रैक्टिव इंडेक्स है जिस मीडियम में आपका लाइट जा रहा है. ठीक है, एंड n1 उस मीडियम का रिफ्रैक्टिव इंडेक्स है जहां से लाइट जा रहा है, ठीक है. So n2 by v minus n1 by u, that will be n2 minus n1 by r. Again I am repeating all the term. r radius of curvature of this surface, n2 जिस मीडियम में आपका लाइट जा रहा है, n1 जिस मीडियम से जा रहा है, v position of image from pole, u position of object from pole. Okay, so this is the significance. I am not deriving because it is wasted of time, and very simple mathematics are there. Okay, ठीक है.
Yes, sir.
Again, हाँ, again if you remember for lens, रियल इमेज का क्या ये था, कौन फंडा था? रियल इमेज के लिए, लेंस के लिए क्या फंडा था? दैट u and v both should be opposite in sign, right? लेंस के लिए u and v both should be opposite in sign for real image. If they are same sign, then image will be virtual. ये भी यहाँ पे भी ट्रू है. ये जैसे आपका लेंस का फॉर्मूला है, यहाँ पे भी वो ट्रू है. अगर u v both are in opposite sign, then image will be real. If both are in same sign, then image will be what?
Same sign. Virtual.
Exactly, virtual. तो लेंस एंड स्फेरिकल सरफेस के लिए क्या होता है आपका? सेम होता है चीजें. बट मिरर के लिए क्या होता है? डिफरेंट होता है. मिरर के लिए क्या है? यू भी जब आपका सेम साइन है, देन यू विल गेट बेसिकली रियल इमेज. इफ दे आर इन ऑपोजिट साइन, यू विल बेसिकली गेट virtual image. You have to keep in mind. Okay, let us solve two problems on this topic. Suppose you have a this kind of medium, okay, and this is basically you have a, this is basically glass, and its refractive index given है 3/2. This glass is surrounded by air, और एयर का रिफ्रैक्टिव इंडेक्स आपको पता है कितना है, 1. ठीक है, and this is the pole. This is the pole. Now a point object is kept at a distance of 30 centimeter. Okay, at a distance of 30 centimeter from pole. So here you have a point object. This distance is 30 centimeter. Okay, radius of curvature of this lens is given, that is r equals to 10 centimeter. Okay, now you have to tell that position of image as well as type of image you have to tell. So again, I will use the same formula. So N2 will be how much? N2 by V minus N1 by U equals to N2 minus N1 by R. So you have to calculate position of image. That means you have to calculate V. So N2 by V. N2 कितना है? 3 by 2V minus N1 by R. N1 कितना है? इस medium का refractive index. So on by N1 by U. So U will be how much? Anju, Rama, Dhiraj,
Minus 30, sir.
exactly, it should be minus 30 because your ray direction is this, and you are getting that distance from pole to object that is opposite to that of positive direction. So obviously this should be minus, right? So overall it will be plus because you already have minus here, you have minus here, so it will be plus. And that should be equals to how much? N2 minus N1. N2 minus N1 by R. So N2 minus N1 कितना है? 1.5 minus 1, so that will be basically 0.5 by R. R कितना है? 10 centimeter. It will be positive, right? Because this is the direction for radius of curvature, and it is same like direction of incident ray. So I'll use 10. So basically this is nothing but 1 by 20 because 0.5 is nothing but 1 by 2, right? So it should be 1 by 20. Okay, so it means 3 by 2 V. That should be equal to how much? 1 by 20 minus 1 by 30. So it means minus 1 by 60, right? Or I can write like this. So you have a 30 minus 20, 30 minus, sorry, minus 30 minus 20 by 60, 600. 30 minus 20 by 600, it means 1 by 60. Okay. So 3 by 2V, that is how much? 1 by 60, which implies V will be 3 into 60 by 2. So basically it will be how much? 90 centimeters. And obviously that image will be what? It will be real image because U is basically minus 30 centimeter and V is basically 90 centimeter. So both are in opposite sign. So image will be real. So image will be from pole to somewhere here, that image, and that distance is basically 90 centimeter. Okay. Is this clear what I'm saying?
Yes, sir.
Now suppose second times. Problem second. Now again you have a glass. You have a glass, okay, and refractive index is same. That is how much? Again, N2 is 3 by 2. Okay, and radius of curvature R equals to 10 centimeter. Okay, and this glass is surrounded by water this time, not by air, but it is surrounded by water. Refractive index of water is, that is N1 4 by 3. And this is the pole of the surface, and this is the principal axis. Now a point object is kept at a distance of, this is a point object, it is kept at a distance of 20 centimeter. At a distance of 20 centimeter. Now you have to calculate. You have to calculate that position of image. That means you have to calculate V. And also you have to mention the type of image as well. So this time that basically the distance of point object that is changed from 30 centimeter to 20 centimeter. पहले वाला problem में कितना था आपका? 30 centimeter थे, right? And this time 20 centimeter. Now you have to calculate. So very simple mathematics is there. If people tell me, I'll solve. बताओ आप लोग.
3 by 2V plus 4 by 60 is equal to
3 by 2V minus, then you have 4 by 60. This should be plus, right? 4 by 60, right? Am I correct, Anju?
yes, sir.
That should be equal to how much? N2 minus N1 by R. So 3 by 2 minus 4 by 3 by r, that is 10.
minus 3 sir.
Minus 3, so you already have minus na. So basically again I am writing n2. n2 कितना है 3 by 2 v minus n1. n1 कितना है 4 by 3. Then you have u. U will be how much? That will be minus, right? Because you have a ray direction this, but that object distance you have to calculate from pole, so it should be opposite sign. So you have to use minus here. So minus 20, and you have minus, so it will be plus. So this you can write like 4 by 3 into 20. So denominator में क्या आएगा आपका 3 into 20. That will be basically 4 by 60, and that should be equal to how much? 3 by 2 minus 4 by 3 divided by r. Okay. कितना आ रहा है देखो. So this is basically 9 minus 8. It means on, right? On by 60 minus. So I can write 3 by 2b. That should be equal to how much? On by 60 minus 4 by 60. So it means कितना हो जाएगा आपका? On by 60 minus 4 by 60. I can write on minus 4 by 60, and on minus 4 is nothing but minus 3. So minus 3 by 60, and this will be gone. 3 कितना आ जाएगा? That will be 20, right? So basically you will get minus 1 by 20. It means v should be equal to how much? 3 by 2 into minus 20. So this will be cancelled, right? You will get 10. So basically how much you will get? Minus 30 centimeter. Minus 30 centimeter. Is this clear? Now this time you see, this time your image will not form at glass. क्यों? क्योंकि आपका देखो v कितना आ गया? Negative आ गया. It means that image will be formed somewhere at negative value. You will get image here, because you are getting minus sign, right? You are getting minus sign. It means image will form here at a distance of 30 centimeter from pole. This distance will be 30 centimeter, and obviously u and v both are in same sign, so your image will be basically what? It will be virtual image. Is it clear what I'm saying? Is this clear what I'm saying, Shekhar?
Yes.
Yes sir.
Rajkishore? Okay. Okay, now last part of your optics, that is. अच्छा, एक चीज मैं आप लोगों को होमवर्क दे रहा हूँ, है ना? वो आप लोग कर लेना. जैसे आपका ऑब्जेक्ट जब इन्फिनिटी पे है ना, इमेज कहाँ पे बनेगा? कॉन्वेक्स कॉन्केव लेंस के लिए. जब फोकस पे है आपका ऑब्जेक्ट, तो इमेज कहाँ पे बनेगा? ठीक है ना? जब इन बिटवीन फोकस एंड इन्फिनिटी, तब आपका इमेज कहाँ पे बनेगा? ये चीज आप थोड़ा देख लेना. वेरी सिंपल थिंग्स आर देयर. I will not teach you because you are learning these things from 12th class. Okay, small things is there, or if you have any doubt, you can ask me anytime. I'll respond. Okay, you have a group. Okay, so last part of your optics, that is Fermat principle. And it came in the year of 1650. And actually it's a great discovery or great achievement of this discovery or this theory. Why? Because before this theory, scientists believe that light will always travel from, when that light is traveling from 2 points, from point A to B, it will always follow the path which will have shortest length. क्या बिलीव था साइंटिस्ट का कि लाइट विल ऑलवेज ट्रैवल फ्रॉम वन पॉइंट टू अनदर पॉइंट. कौन सा पाथ को फॉलो करेगा? द पाथ दैट इज शॉर्टेस्ट इन बिटवीन देम. बट दिस डिस्कवरी shows something else. This discovery shows something else. Light will always not follow that shortest path, but rather it will follow the path in which it will take shortest time. In which it will take shortest time. ऐसा हमेशा जरूरी नहीं है कि ये shortest path को ही follow करेगा. Sometimes it will follow that shortest path, but sometimes not. ठीक है? So what is the conclusion of this theory? This theory, and it is a great successful actually. This theory tells that light will pass from one point to another point. It will not follow that shortest path, but rather it will follow the path in which it will take short time or least time. Okay, So for example, you have two kind of things. Then you can understand that why this theory is successful. Suppose you have a phenomenon of reflection. Suppose you have a phenomenon of reflection. So you have plane surface, a ray is incident. So suppose this is the point A. This is the point A. From here, a ray is incident on the surface at a point B. And it goes to point C. Then the path followed by this ray, the path followed by this ray from going from A to C, that is actually shortest path. That is actually shortest path. How will prove? So ये आपका कौन सा point है? C है. Let us assume at a height of h. At a height of h. तो मैं इस surface से नीचे h height पे एक point choose करूंगा, that is C dash. That is your C dash. Okay. So now if I join that B and C dash, if I join B and C dash, then this path B C dash AB, it will be actually straight line. It will be actually A से जो C dash है, it will be actually straight line. Why? Because this angle will be same. ये angle आपका same हो जाएगा. So what I'm saying, you have a light. A से C जा रहा है by reflection from point B, and if this height is h, I'll take a point C dash at the same height. So this distance B C dash will be same as BC. Why? Because this height is same and this base is same. So BC, this is like a triangle, hypotenuse of triangle, right? So this distance should be same as this. तो मैं कह सकता हूं कि लाइट यहां से A से B, A से C जा रहा है by this path A to B plus B to C. It is same as light A से B जा रहा है, then B से C जा रहा है. क्यों? क्योंकि ये वाला path same है. And if you see, this graph itself is saying this line is actually straight line. ये line क्या है? Straight line है ना? Is it clear what I'm saying? This line is straight line. So हमको पता है कि दो पॉइंट के बीच में सबसे शॉर्टेस्ट जो डिस्टेंस है, that is actually straight line. दो पॉइंट के बीच में जो shortest distance होता है, that is straight line. So when there is a reflection, then that path followed by this ray, that will be actually shortest in distance. Also, it is shortest in time as well. अगर distance small है, I can also say that time will also be shortest, because we know that time is nothing but what? Distance by velocity, right? So for reflection of light, that ray followed that shortest path. Suppose आपके पास दूसरा एक path है. Suppose मान लो ये path अगर आपका ray follow नहीं करके, suppose मान लो ये point है E, यहाँ पे strike कर रहा है. So it is like this. It is striking here, then it is reflecting, and it is going like this. It is going like this. So again, if I join that line, यहाँ से E से आपका suppose मान लो मैं join कर रहा हूँ C prime तक. Okay. Again, this distance will be same from triangular hypothesis, क्योंकि ये base और आपका height जो same हो गया. So this distance E C dash will be same as EC. It will be same. Why? Because for both triangle, the base and height is same. So hypotenuse will be same. So मैं ये कह सकता हूँ कि आपका light भाई यहाँ से A से C E गया and E से C गया, that is same as A से E गया, then E से C prime गया. ठीक है? But you see, this path is not shortest. Between A and C prime, this path is not shortest. Because why? Because this path is no longer straight line, but it is like curve. And this path is not true actually. Ray will never follow this kind of path. Okay. Similarly, if I choose this point, suppose you have a F point and ray is striking here, and it is again going to point C. It's going to point C, and if I extend this path and join with C prime, then this FC dash should be same as FC. because both have same base and same height, same concept. But you see this path a c prime by this path AFC, that is not shortest, because why? This is not a straight line and this is a curve. So this path will not followed by this ray. So actually, whenever there is a reflection, that ray will always follow that path which will have shortest distance. Okay, not only shortest distance, it will be also shortest in time. Okay, but suppose you have a refraction. Suppose you have a refraction of ray. Suppose you have a refraction of ray. Suppose this is the interface, this medium having refractive index n1, and this medium having refractive index n2, and this is your normal. And a ray is striking here. Okay. Suppose this is the original point is A and it's striking here, and this two medium is having different refractive index, and let us assume n2 is greater than n1. Then what will happen? Suppose this is the angle of incident, and then a ray will bend towards the normal, obviously, right? And suppose this point is end point is B. Now I can, from this graph itself, I can clearly say this path is not shortest. Is this path shortest? That ray followed the, to going from point A to B, this is not shortest because this path is not straight line, and we know shortest path between 2 points, that is a straight line, but this path is not straight line. Is it clear what I'm saying? Is this clear what I'm saying? Path followed by this ray from going to point A to B, that is not shortest, because why? Because this path is not straight line. So like you have a curve, but this path is following. Then Fermat came to that picture. What he said, that he said actually whatever belief was there earlier, that shortest path followed by ray from going from one point to another point, that is not true. Shortest path will be replaced by shortest time. ठीक है ना? Actually यहाँ से यहाँ जाने के लिए ये रे इस path को क्यों follow किया है? Because from going from a point A to B, it will take shortest time. It will take shortest time. Why? That I'll give you a real example. Actually shortest path किस तरह की होगा? Suppose होता है अगर यहाँ से suppose मान लो B में जाता, shortest path it should be straight line. It will be like this. But यहाँ पे तो आपको curve दिख रहा है. But this curve path is followed by this ray. Why? I am giving you real example. Suppose मान लो आपके पास एक बहुत बड़ा घर है, और उसमें पूरा पानी भरा हुआ है. एक एग्जाम्पल दे रहा हूँ ना, पूरा पानी भरा हुआ है, ठीक है. ठीक है. एंड सपोज मान लो यहाँ पे आपका एक बोट है. सपोज मान लो यहाँ पे आपका एक बोट है. आप सपोज मान लो यहाँ पे खड़े हो. आप सपोज मान लो यहीं पे खड़ा हो. आपको ये बोट पकड़नी है ना. इस बोट को बोट में जाके आपको बैठनी है. तो एक तो रास्ता क्या है भाई, स्ट्रेट इसको फॉलो करो, ठीक है. और दूसरा रास्ता क्या है, आप इस ऊपर से चले जाओ, है ना, और बैठो. आप कौन सा रास्ता को फॉलो करोगे बताओ? ये स्ट्रेट रास्ते को फॉलो करोगे या ऊपर सीधा जाके बैठोगे?
स्ट्रेट लाइन.
नहीं, स्ट्रेट लाइन क्यों? इसमें तो काफी आपका टाइम लग जाएगा भाई. ये आपका वाटर है, वाटर में स्विमिंग करना है. ये आपका ऊपर क्या है, एयर है. आप आराम से जल्दी यहाँ विद इन अ फ्रैक्शन ऑफ टाइम यहाँ आ सकते हो, फिर पकड़ लो. इसमें आप जाओगे तो इसमें तो वाटर है ना, स्विम करना पड़ेगा, काफी टाइम लगेगा नहीं. So suppose I am here, I'll not follow this path because it will take long time. I have to swim, and that time I'll have very less speed. So I'll take a lot of time to reach here on that boat. But this side you have air, I'll come quickly to this point, है ना. फर्स्ट भाग के हम यहाँ आ सकते हैं, फिर यहाँ से पकड़ लेंगे इसको, ठीक है ना. Is clear what I'm saying?
Yes, sir.
So light actually will not follow. These are a kind of rough example. So what I'm trying to say, light will not follow a straight line. It will take that path at which it will take least time. from point A to B, it will follow only that path. In that path, it will take least time, not shortest distance. Okay. So basically, suppose मान लो A से B जा रहे हो, कई सारे पाथ पॉसिबल है. सपोज मान लो S1 है, फिर आपका S2 है, फिर आपका S3 है, एंड सो ऑन. So basically, time as a function of what? Time as a function of path followed by this ray, है ना. ये रे इधर भी जा सकते हैं पॉइंट बी जाने के लिए, ये भी फॉलो कर सकते हैं, ये भी फॉलो कर सकते हैं. तो यहाँ से यहाँ जाने के लिए आपको टाइम जो लगेगा, कौन सा पाथ आप फॉलो कर रहे हो उसके ऊपर डिपेंड करेगा. बट अकॉर्डिंग टू लीस्ट टाइम, अगर लीस्ट टाइम है तो इसके लिए मैं क्या लिख सकता हूँ, दैट dt by ds दैट शुड बी 0. एस क्या है यहाँ पे, एस क्या है, जो आपका डिस्टेंस है. ये सपोज मान लो यहाँ से यहाँ जा रहे हैं, है ना. सो टी एज ए फंक्शन ऑफ व्हाट, डिस्टेंस, और पाथ, जो पाथ का डिस्टेंस है दैट इज एस. सो फॉर लीस्ट पाथ व्हाट आई कैन से dt by ds इक्वल्स टू 0. ठीक है. एंड ऑल्सो अनदर थिंग इज इम्पोर्टेंट, नॉट ओनली इन अदर वर्ड्स में अगर कहना चाहोगे कि लिस्ट टाइम लगेगा, तो उसको अदर शॉर्ट में भी, अदर वर्ड्स में भी कह सकते हो कि सपोज मान लो आपका रे ए से बी पॉइंट में जा रहा है, तो उस पाथ को फॉलो करेगा जिसमें उसका सबसे कम ऑप्टिकल पाथ हो, सबसे कम ऑप्टिकल पाथ हो, है ना. सो रे विल गो फ्रॉम वन पॉइंट टू अनदर पॉइंट इन व्हिच इट विल हैव स्मॉलेस्ट ऑप्टिकल पाथ, है ना. जैसे ऑप्टिकल पाथ वाटर का ज्यादा हो जाता है, क्योंकि ऑप्टिकल पाथ आपको पता है रिफ्रैक्टिव इंडेक्स यू हैव टू टेक इनटू अकाउंट. एंड फॉर वाटर and other denser medium, it will have, you will have higher refractive index, so you will have higher optical path, right. Why this ray bent here, यहाँ पे बेंड क्यों हुआ है, क्योंकि सपोज मान लो इस पाथ को अगर फॉलो करते, इतना पाथ उसका क्या वाटर में ट्रेवल करना पड़ता, और इसमें इसका क्या ऑप्टिकल पाथ बढ़ जाता नहीं. इसीलिए इस रे को इसने इस तरह की फॉलो किया है ताकि वाटर में कम चले, क्योंकि वाटर में जैसे चलोगे तो वैसे आपका क्या हो जाएगा, आपका ऑप्टिकल पाथ बढ़ जाएगा. सपोज मान लो यहाँ से आप बी पॉइंट में जा रहे हो बाई स्ट्रेट लाइन, देन आपको इतना पाथ आपको क्या जाना पड़ रहा है, ऑप्टिकल पाथ में जाना पड़ रहा है. यू कैन क्लियरली सी दिस पाथ इज हायर देन दिस, है ना. तो रे हमेशा उस पाथ को फॉलो करेगा एक पॉइंट से दूसरे पॉइंट में जाने के लिए जिसमें उसका ऑप्टिकल पाथ स्मॉलेस्ट हो. सो यू हैव टू कीप इन माइंड स्मॉलेस्ट टाइम and smallest optical path. So shortest path follow नहीं करेगा, smallest time and smallest optical path. Okay, that you have to keep in mind. Okay, so this is all about your optics. So इसको आप लोग प्रैक्टिस करो, है ना, और ग्रुप में ये आप डाउट भेजो, है ना. And I taught you first time, so if I from my side if I made any mistake, please forgive me, and you can ask me anytime any question. Okay. So I should stop here, okay? And I wish you all the best to all my students.
Thank you, sir.
Thank you, sir.
Good night, sir.